things can impact the local climate record. Changes in instrumentation, such as going from human-read maximum-minimum spin thermometers to automated readout digital thermometers. Station moves, especially if they involve changes in elevation and/or exposure. Changes in observation time, such as changing from an afternoon to a morning recording format. Changes in observers can impact the local climate record, especially with respect to difficult to measure things like snowfall. Changes in environmental conditions around the recording site, as with increases or decreases in vegetative cover and urbanization. The climate period used for data analysis can also impact results of the local climate record by changing climatic trends. Climate trends are complicated by complex terrain. Recording sites in mountain valleys and cold air pooling basins tend to respond differently to climate changes than do locations in middle elevation thermal belts and on slopes and ridges. Recording sites can also respond differently depending upon aspect, such as between southern and northern exposures. Recording locations are also impacted by mean orographic airflow trajectories, with sites along the windward rising air side of a mountain barrier tending to be cooler than a site on the downslope sinking air side. The bottom line? All these factors and many more must be considered and adjusted for, or the sign and magnitude of local changes in climate may be in error and generate a false local trend. This is critically important given that global climate change consists of the summation of all local changes. Outside of Wytheville, the weather station in Burke's Garden has the longest record period across southwestern Virginia. Burke's Garden is also one of the high mountain basins that I am using in my graduate field research. The basin has remained relatively unchanged during the bulk of its long data period and is a good location to use for identification of long-term trends. Other stations across southwestern Virginia generally follow the trends to be shown, especially when adjusting them to remove local factors not directly related to climate. But it can become complicated, and this presentation is far too short to go into all the details and to show lots of different sites I have studied. The mean annual temperature trend is nearly flat when looking at the complete record period from 1898 to 2020, with only a slight 0.2 degree Fahrenheit decrease in mean annual temperature. Note that I have filtered the data to remove any year with 30 or more missing days. A different trend is observed when using the current climate period from 1991 to 2020. A 1.3 degree Fahrenheit increase in the mean annual temperature is spread evenly across 1.3 degree increases in both the mean annual maximum and the mean annual minimum, not shown. The length of the growing season, defined by the number of days between 32 degree temperature, shows a positive regressional trend, with a 14-day increase in the length of the growing season during the 1898 to 2020 period. A 15-day increase has been observed during the present 1991 to 2020 climatic period. A positive aspect, this has increased the growing season from 3.9 to 4.3 months in a location where the growing season has been as short as 2.7 months. A negative aspect has been an increase in pest and invasive species. Data-supported trends in annual precipitation generally show the strongest climate change impacts within the southern Appalachians. A strong increase in total annual precipitation during the past 61 years is echoed by current increases during the 1991 to 2020 climate period in Burke's Garden. This same trend has been observed since precipitation recording started within the much wetter Big Cherry Lake basin of the High Knob Massif, where the annual average is greater than the wettest single year ever observed in Burke's Garden since the late 1800s. Warmer air holds more water vapor, and this naturally tends to increase precipitation and or drying through increased evapotranspiration. The latest IPCC report recognizes the potential for both increases in extreme precipitation events and increases in droughts across different regions with global warming. While total precipitation has increased greatly, there has been a dramatic decrease in mean seasonal snowfall during both the present 1991 to 2020 climate period and also during the past 6 decades. This is a trend that is again echoed by orographic locations along the expanse of the southern and central Appalachians. A word of wisdom for all want-to-be climatologists: if studying snowfall trends, be certain to use favorable orographic locations to help obtain more accurate results, given that a single event can greatly skew a season above average in downslope-dominated locations that typically receive limited annual and seasonal snowfall. Locations such as the crest of the Great Smokies, Roan Mountain, Mount Rogers, and, of course, the High Knob Massif, Snowshoe Mountain, and Canaan Mountain will more accurately reflect snowfall trends related to changes in climate. Shifting the focus back to national and global temperature trends finds a positive linear regression trend of 1.55 degrees per century for the lower 48 states since 1895. This is a little less than the 1.9 degree Fahrenheit warming reported by the latest IPCC report for planet Earth. A composite of all global temperature data sets, courtesy of the United Kingdom's National Weather Service Office, finds a rather good correlation with warming since 1850 and conclusion of the Little Ice Age, that approximately averages out to meet the latest IPCC value. Due to all sources of possible error related to recording at Earth's surface, satellites have now become a preferred way by many to monitor the climate system. Satellites calculate warming for the lower, middle, and upper troposphere at the tropopoles, as well as for the stratosphere. These data sets are freely available online. Looking at the lower troposphere finds that the mean global warming since 1979, when the satellite record period started, has been only about 25% of the IPCC value reported for the surface. As of December 2020, the University of Alabama calculated value was 0.27 degrees Celsius, or about half a degree Fahrenheit. There are many reasons for this difference between the satellite record and the surface record, to include all the local factors that act to impact climate that I talked about at the beginning of this discussion. The satellite dataset will become more important for planet Earth as more data are collected into future decades. A map of the globe reveals the amount of satellite estimated warming per decade. Note the area of mean cooling over the North Atlantic above the region where weakening of the Atlantic meridional circulation is occurring and predicted to continue. Also observe that some of the largest satellite-derived warming has been estimated across Eastern Europe and otherwise is concentrated around the Arctic at high latitudes. Even with zero climate change, the greatest threat to the natural world, and by definition to human beings, is The big reveal: human beings. We are our greatest threat. A local example of negative human impact finds a great increase in logging across the High Knob area that is fragmenting intact forests, threatening rich biodiversity, reducing carbon storage, and acting to greatly diminish longer-term potential for tourism and more widespread and long-lasting economic benefits. High Knob did have the largest mass of intact forest in the Clinch and Powell River basins before thousands of acres of logging that have recently been done, or being done now, and that are being proposed for the future. High Knob is part of the richest biodiversity in the continental United States and the North American continent, and a situation like this reminds me of the Ron Coleman poem, Cool Green Cumberlands, in which one line reads, "Some would have mindlessly destroyed me." A look at 12 different areas of recent logging across the High Knob Massif area finds that outside of a few selective cuts, most of this has been biomass logging in which all vegetation is cut and removed. Not including the above, an additional 133 logging units are proposed to be cut across a 13,087 acre area on public land between Eastone Gap and Duffield. A map of the 133 proposed logging units is shown here, and more information can be obtained by contacting the Clinch Ranger District Office in Norton. A breakdown of the logging units by age finds a mean unit age of 100 years, with numerous separate tracts combined together to generate a total of 96 on this chart. If all this were not enough, an additional 1,600 acres of logging on private land is proposed for cutting, which includes 1,200 acres within vicinity of the High Knob Lookout Tower. Regardless of climate change, the biologically rich High Knob area is under tremendous pressure and increasing threat, but is only a single example of what is being done across planet Earth. Remember the concept of 8 billion backyards that are projected to increase to more than 10 billion in coming decades? Humans are the first species to ever dominate Earth with explicit ability to destroy themselves and all other living things on the planet. Earth has proven it can survive climate change over its 4.6 billion year history. But a much bigger concern is, can it survive human beings? The need to balance human impacts is why proforestation is favored for preservation of biological diversity, for storage of carbon, and for the reduction of human forcing on the climate system. If you want to learn more about proforestation, I would highly recommend this paper by Dr. William Mumal. I hope this short series has given you some new ways to think about climate change. As the dominant species, it is our responsibility to leave planet Earth better than when we were created. It is our responsibility to treat each other and the world around us with respect. For all living things, that is really the main message and the ultimate bottom line.